This program has been prepared to assist drivers of Tiger coaches to have a full understanding of the driving controls, warning systems, daily maintenance, and procedures that can be carried out in the event of a breakdown. For the benefit of those drivers who travel further afield in more remote conditions, additional areas of fault diagnosis and emergency procedures will be covered. It's important from a safety point of view that you seek further advice should you have any doubt concerning the information contained in this program. As a general rule, always turn off the battery isolation switch when inspecting or conducting a minor repair on the vehicle. And if you jack the vehicle up, always ensure that the park brake is applied. Chock the road wheels and only use suitable jacks and support blocks. Before proceeding, let's briefly look at the general vehicle specification. The Leyland Tiger is fitted with a horizontal 11-litre 6-cylinder turbocharged engine, which is mounted horizontally midway in the chassis. The power output will vary according to specification, and in the main ranges from 215 to 260 brake horsepower. With the transmission system, there are three basic forms of gearbox which can be fitted. First, a 5-speed Hydracyclic unit which has an integral retarder. Drive from the engine to the gearbox is via a fluid coupling. The controls for the gearbox can either be fully or semi-automatic. As an alternative, providing the engine power output is not in excess of 218 brake horsepower, a 5-speed Pneumocyclic gearbox with a fluid coupling can be fitted. Again, the gearbox controls can be fully or semi-automatic. To complete the range, a ZF 6-speed synchromesh unit can be installed and, if required, is available with a splitter unit to give 11 or 12 speeds, depending on specification. When this unit is used, a twin-plate Dana Spicer clutch is installed, which is operated by a conventional clutch pedal with hydraulic air assistance. From the gearbox, the power is transmitted via a one-piece prop shaft to a single-speed hypoid rear axle. Moving to the front axle, this is a conventional beam-type construction. Steering assistance is provided by an integral hydraulic steering unit. Air suspension is fitted to both the front and rear axles. Although conventional leaf springs may be used as an alternative. The braking system is of a direct air design, and the foot brake has dual operation to give independent operation to the front and rear brakes. Spring brakes on the rear axle provide a park brake facility. To supplement the braking system, retarder units can be fitted. With the Hydracyclic gearbox, the retarder is combined within the gearbox. However, the Pneumocyclic and ZF units can have the Telma electric retarder fitted either to the rear of the gearbox or to the prop shaft driveline. If no retarder is fitted, the engine will have an air-operated exhaust brake installed in the exhaust manifold. The first area we will be looking at is the cooling system. And to assist with the maintenance and fault diagnosis, let's briefly look at the layout. The TL11 engine has a water pump at the front of the engine, which is gear-driven. When the engine is running, water is pumped first to the heat exchanger, which provides cooling for the engine oil. The water then flows from the heat exchanger to the engine cylinder block to give cooling to the cylinders and pistons. When the water leaves the engine, it is collected by this water rail. Located at the end is a thermostat, which diverts the water back to the pump via this pipe if the water is cold. When the water temperature increases, the thermostat opens at about 82 degrees centigrade and allows water to travel through to the radiator and then return to the engine. On some vehicles, an automatic radiator shutter is fitted, which is controlled by a sensor unit in the water pipe. This is set to open the shutter when the water temperature reaches 85 degrees centigrade. A hydraulic cooling fan is fitted, which is driven from the power steering pump on the engine. The fan will run all the time the engine is running, but at a relatively low speed, until the water temperature reaches 90 degrees centigrade. At this point, a second sensor unit switches the fan to full speed. Installed on the thermostat housing is a temperature transmitter, which operates a temperature gauge on the instrument panel. In addition, a high engine temperature switch is fitted, which operates the light and warning buzzer if the temperature reaches 96 degrees centigrade. The water header tank has two probes fitted, which operate the low warning light and buzzer if the water level drops below the probes in the bottom of the tank. With the correct water level in the header tank, it should be half full. The remaining area above this is for expansion. On the header tank, there are two filler caps, one on the top and one on the side. On most header tank installations, you will only be able to gain access to the filler on the side, which will allow you to fill half of the tank. Should you have access to both, use the side filler only. During normal operation, if the low water light comes on with the warning buzzer, it's important to stop the vehicle and check the water level in the header tank. However, before doing so, remember the system is pressurized and the cap must be released slowly to allow the system to depressurize. If the header tank is empty, before adding water, carry out a brief check for any signs of major water leakage from the engine. Pay particular attention to the water pump, radiator, water pipes and hoses. If the water loss is only slight, the warning buzzer and light should cancel after adding a relatively small quantity of water to the header tank. As a general rule, if the water loss is slow, there will be a period when the low water warning light will flash intermittently, particularly when the vehicle corners due to the water surging in the header tank. However, if the light comes on without passing through this intermediate period, the water leak will be more serious. Moving on now to the high engine temperature light. This is triggered should the water temperature reach 96 degrees centigrade. In this condition, you must stop the vehicle, as continued operation may cause seizure of the pistons and give results like this. If the high engine temperature light is accompanied by the low water light, the temperature increase is due to a breakdown in the water circulation. On the assumption that the water level is in order, check the temperature gauge reading, and should this be normal, proceed with caution if authorized, but pay special attention to the temperature gauge and low warning indicator. Should the reading on the temperature gauge be high, check that the shutter on the radiator is open fully. If it's in order, start the engine and increase the revs. The hydraulic fan should be heard to roar like this if it's in operation. As a general rule, providing the engine has sufficient water and you don't exceed the maximum running temperature, you can proceed conducting periodic stops to allow the engine to cool down. You will find that by switching on the saloon heaters, this will help to reduce the running temperature. An oil light on the instrument panel will illuminate if the oil pressure drops below 7 pounds per square inch. In this instance, the buzzer does not sound. When this condition arises, it's important to stop the engine as quickly as possible to avoid major seizure on the engine crankshaft. For guidance, the engine will only run for approximately 30 seconds before seizure if it's on full load without oil pressure. Therefore, prompt action to this warning is imperative. The most likely cause of this condition is due to loss of oil. In this instance, first check the oil level in the sump. Should there be no reading on the dipstick, carry out a brief inspection for a major oil leak. And pay particular attention to the external oil pipes supplying the heat exchanger, which is on the left-hand side of the engine, compressor, and fuel injection pump, which is on top of the engine, and the turbocharger supply and return pipes, which are on the right-hand side of the engine. To complete in this area, check for oil leaking from the exhaust tailpipe. If it is, this indicates a failure in the turbocharger. This latter condition will be accompanied by excessive blue smoke from the exhaust during normal running. If the oil level had been correct, start and idle the engine for a few moments and check the oil pressure gauge reading. If no oil pressure is visible, stop the engine immediately. Alternatively, if a pressure of 15 pounds per square inch is indicated at idle, increase the engine revs to a fast idle, and the pressure should increase up to a maximum of 60 pounds per square inch. Although it only happens very infrequently, this latter condition would indicate a possible fault in the warning system. However, do not move the vehicle unless authorized. In practice, if the engine is losing oil due, for example, to a fractured oil pipe, you will probably find that as the oil level drops, the light will flash intermittently due to oil surge in the sump before a continuous light is evident. Therefore, a degree of warning is generally given. In order to carry out an oil level check, make sure the vehicle is on level ground. Start the engine and run for a few minutes. Check the oil level as soon as the engine is shut down. Providing the level is between the maximum and minimum mark on the dipstick, it is correct. Never be tempted to overfill the engine. Before discussing the brake warning system, let's look at the basic brake system. An air compressor driven by the engine supplies air to 4 air tanks, which supply the front brakes, the rear brakes, the park brakes. The auxiliary components, such as the suspension and doors, are fed from an auxiliary tank. When the foot brake is applied during normal operation, air passes from the front tank out to the brake chambers. At the same time, air is passed to the rear brakes, which gives dual operation for safety. Moving now to the park brake system. If the park brake is on, there is no air in the spring brakes, and a strong spring within these units applies the rear brakes. When the park brake is moved to the release position, air pushes the springs back to release the brakes. It should be noted that a pressure of at least 65 pounds per square inch is required to fully release the spring brakes. Therefore, if the pressure supply in the park tank drops below this figure, the brakes will automatically start to apply. On the instrument panel, there are 3 air gauges. Air 1 for the front brakes, Air 2 for the rear brakes, and Air 3 for the park brake. The auxiliary tank doesn't have a gauge. In addition, there is a low air warning light and buzzer on the instrument panel, and if the pressure in any one of these tanks drops below 75 pounds per square inch, including the auxiliary tank, the warning light and buzzer are triggered. To summarize, with this braking arrangement, if the front brake circuit fails, you still have foot brake operation on the rear brakes plus the park brake. If, on the other hand, the rear foot brake circuit fails, the front brakes are still operative, plus the park brake. In the unlikely situation where the foot brake fails completely on front and rear, the park brake is still available. From a safety aspect, always check the braking system is fully charged and that the low air warning buzzer has cancelled before moving the vehicle at the commencement of duty. If, for example, you move the vehicle before the auxiliary tank is charged, the suspension may not have inflated correctly, Or if your vehicle has a pneumocyclic gearbox, which is air-operated, the gears may slip, causing severe damage. During normal driving, if the low air light and buzzer are triggered, you should immediately check the pressure readings on the 3 air gauges. If, for example, Air 3 is showing a drop in pressure, it's important to maneuver the vehicle to a safe parking space as quickly as possible, because continued air loss, below 65 pounds per square inch, will cause the spring brakes to apply automatically, and your vehicle may be left stranded in a dangerous position. Should the pressure loss be in Air 1 or 2, you must again stop the vehicle as soon as possible to investigate the problem. If the warning system becomes operative and all 3 gauges are at the correct pressure, the problem may be an air loss in the auxiliary tank. Again, in this instance, you must stop. Before reporting the problem, there are a few checks that you can make to assist the breakdown team in identifying the fault area. With the foot brake off and the park brake applied, run the engine. If the air system recharges to full pressure, this indicates that the compressor is in order. For example, if the pressure in Air 1 or Air 2 only drops when the foot brake is applied, this indicates a problem in the brake chambers or pipework. In the case of Air 3, if this system only drops when the park brake is released, this points to a problem in the spring brake or pipework. Assuming the air gauges are correct and the warning system is operative, as previously indicated, the problem may be in the auxiliary tank. To check this system, stop the engine and operate the foot brake to drop the pressure in Air 1 and 2 down to approximately half pressure. Restart the engine, and if the pressure does not build up in Air 1 and 2, the auxiliary fault is due to a possible compressor failure. Alternatively, if the air does build up, stop the engine and attempt to operate the entrance door if it's air-operated. Should it fail to operate, this confirms that the auxiliary tank is depleted and either not receiving air from the main system, or there is a major leak on an auxiliary component, such as the air suspension. Moving now to the remaining warning lights. A fire warning light can be fitted if specified, which is triggered and is accompanied by a warning buzzer if the engine compartment becomes overheated. If the vehicle has a Hydracyclic transmission fitted, there are 2 warning lights. This one comes on if oil temperature in the gearbox reaches 125 degrees centigrade. This high oil temperature will only be reached normally if the retarder is being used for a prolonged period of hill descent. And the gearbox control system for the gearbox will cut out the retarder second stage operation until the temperature has dropped. The remaining light will come on if the transmission goes into a lock-up condition. Details of this will be given later in the program. However, briefly from the driving point of view, the gearbox will have locked in 5th gear due to a fault in the control system, or if the road wheels have been locked under heavy braking. The charge warning light on this side of the panel identifies whether the alternator is charging the battery. The light should come on when the ignition is switched on and go out when the engine is running at a fast idle. If the light does not come on initially, or alternatively fails to go out when the engine is running, there is a fault in the charging system. Additional fault conditions and procedures on the charging system will be covered in the General Fault Diagnosis section of this program. On more recent Tiger coaches, skid check anti-lock braking systems can be fitted. In order to understand the warning system, let's look at the principles involved in the braking circuit. When this system is fitted, the dual operation of the front and rear brakes is retained. With skid check, electrical sensor units fitted to each wheel monitor the wheel speed and, in conjunction with an electrical control unit, are able to control the imminent skid condition should it arise on either the front or rear axle during heavy braking or when braking on adverse road surfaces. For example, if the rear brakes approach a skid condition, the sensor units indicate this information to the control unit, which in turn signals this air control valve electrically to release the brakes briefly until the skid condition has passed. At this point, the control unit will allow the valve to reapply the brakes, providing, of course, the brakes are still applied. This on-off cycle of the brakes will continue in rapid succession if the skid condition is repeated. If this condition had occurred on the front axle, the same sequence of events would happen. Because the front and rear axles have independent skid check controls, if a fault develops in the front system, it will revert back to full normal braking, leaving the rear axle still operating under control of skid check. To maintain vehicle stability, if the rear axle control fails, the skid check on the front axle is shut down and both axles revert back to normal braking. When a retarder is fitted to a vehicle with skid check, there are conditions whereby the skid check control will switch off the retarder. For example, if the retarder is in operation, either independently or combined with the brake application, should a skid condition approach, the control unit, in conjunction with this separate control system, will switch the retarder off for 1.5 to 2 seconds and release the vehicle brakes, as previously explained. The retarder and the brake release cycle will continue automatically until the skid condition has passed. A warning lamp is mounted in the driver's instrument panel, which gives an indication whether the skid check is operating correctly. When the ignition is switched on, the lamp should come on for approximately 1.5 seconds and go off. Normally, the lamp will only flash once and then stay off. However, on some vehicles, the lamp may flash a second time when starting up. It should not come on again except if a fault develops. If the lamp fails to flash or comes on and stays on at startup or comes on at any other time, there is a system fault which must be rectified. However, there are two unusual driving conditions that can cause the light to come on: excessive spin on one of the driving axle wheels on a slippery surface, or if the rear wheels are locked by operating the park brake control. It should be noted that this section of the braking system is not controlled by the skid check system. Remember, if the warning light stays on or comes on during normal driving, this means that the skid check is not in operation and your vehicle braking is reverted back to standard operation. Therefore, normal care will have to be exercised if braking on poor road surfaces. In view of the importance of the warning lights and buzzer operation to prevent costly damage and maintain vehicle safety, it's important to ensure that the systems function correctly. Therefore, operate this test button to trigger the warning lights and buzzers at the commencement of duty and at any other convenient time during vehicle operation. As outlined earlier in this program, the Tiger can be fitted with a number of different gearboxes and gear control systems. Although the basic operation of the gear change selector may be understood by those drivers already using the vehicles, there are a number of features and inhibitions involved which are not as evident. First, let's consider the operation of the Hydracyclic gearbox with a fully automatic control. The gearbox has 5 forward gears and reverse. Gear application is by oil pressure, which is generated by a pump in the gearbox. When the change speed lever is placed in A, this signals the control panel, which in turn signals the hydraulic unit on the gearbox to engage second gear. As the vehicle accelerates and the speed increases, a speed sensor transmits the road speed to the control panel, and at a predetermined speed, the panel releases second gear and engages third. This sequence of events continues through to 5th gear. If the road speed decreases, the control panel signals the gearbox to change down through the gears back to second. If a first gear start is required, the change speed lever is placed in H and then into A. The vehicle will now start in first and change up automatically to fifth and return to second as the speed decreases. When H is initially selected with the vehicle at rest, the gearbox will not change up from first gear. If, for example, the vehicle is in A and at a road speed when third gear is engaged, if you wish to hold that gear, in the case of a hill descent or for any other reason, move the change speed lever to H. This will stop any further up changes. However, should the road speed decrease sufficiently, the gearbox will down change to second gear and then hold that gear. And if the road speed decreases still further, it'll return to first gear. The transmission control has a kickdown facility which comes into operation when the throttle is fully depressed. When this is in operation, the change-up speeds in each gear are higher. In addition, if the vehicle starts in second gear and then the throttle is fully depressed, the gearbox will drop down into first gear, providing the road speed is not too high. The kickdown to a low gear will also occur in the higher gears, providing the speeds are low enough in that particular gear. It should be noted that if the gearbox changes down when H is selected, then the gear changes will tend to be abrupt. The reverse gear within the gearbox also provides a retarder function to supplement the main vehicle braking system on long hill descents. Two levels of retardation are available, which are controlled by a switch on the foot brake, or alternatively, a hand-operated switch. If your vehicle has a pneumocyclic gearbox with a fully automatic control, the functions of the change speed and automatic control systems is identical to that of the Hydracyclic. However, the gear actuation is by air pressure supplied by the auxiliary air tank. This gearbox type does not have an integral retarder. However, a separate Telma electric retarder can be fitted. From the driving point of view, because the gearbox is air-operated, always ensure that the air system is fully charged before moving the vehicle. Otherwise, the gears will slip, causing severe damage within the gearbox. The control for the Telma retarder is hand-operated and has 4 levels of retardation available. To avoid over-braking, always pause briefly before applying each of the stages. As an alternative to the automatic controls, both the Hydracyclic and Pneumocyclic gearboxes can have semi-automatic controls. First, the Hydracyclic. The gear change control has separate positions for each gear, which in general terms can be selected as required. However, the control system will only allow first, second and third gears to be selected when the vehicle is stationary. In addition, if a down change is attempted at too high a road speed for the lower gear to be selected, the gearbox will not change down until the road speed has decreased to the correct level. This safety feature is to avoid an overspeed condition of the engine. The controls for the retarder remain the same as before. Moving now to the pneumocyclic gearbox fitted with semi-automatic controls. This system does not have any protection devices fitted, with the exception of a mechanical inhibitor in the change speed gate, which ensures that when changing down from fifth, you must first pass through the fourth gear position before selecting any of the lower gears. Because there is no speed inhibition on the controls, it's important to take a mental note of the maximum road speed in each gear to avoid overspeeding the engine when changing down. Pay particular attention to the wide step between fourth and fifth gears. For example, if your vehicle is geared to give 70 miles per hour, fourth gear should not be selected until the road speed is reduced to 50 miles per hour. With any gearbox with a semi-automatic control, when changing up, always lift off the accelerator and pause briefly with the change speed lever in the neutral position before engaging the high gear. Failure to do this will produce shock load on the transmission, resulting in long-term failure of items such as the brake bands and clutch plates in the gearbox. As outlined in the general vehicle specification, if the vehicle has a ZF gearbox fitted, it has a conventional manual gear change. In the case of a 6-speed unit, gear changes are straightforward. However, if the unit has a splitter unit, you should be aware of its operation. For example, if the vehicle is in low 4th and you require a slightly higher gear, move the selector switch to the high position on the gear lever. At this stage, nothing will happen. However, when the clutch is pressed, the splitter unit changes into high 4th. If the clutch pedal is pressed and released too rapidly, you may find that the splitter does not have sufficient time to change correctly. Therefore, a slight pause with the clutch depressed is required. To complete a down split, again it can be pre-selected in the same manner, and the shift will be completed when the clutch is depressed. Although the gearbox has synchromesh units, you should apply the correct use of throttle and clutch to match road and engine speed to give a smooth up and down change. To complete in the driving control area, some vehicles may be fitted with a road speed limiter to control the maximum speed to 70 miles per hour. With the accelerator pedal fully depressed, as the vehicle approaches 70 miles per hour, the special road speed control gradually moves the air throttle cylinder back to reduce the amount of fuel being delivered to the engine. This movement continues until the engine power is reduced to a level just sufficient to propel the vehicle at 70 miles per hour. As road speed falls, the control system moves the air throttle cylinder forward to increase the engine power. The speed limiter is extremely sensitive and will control the speed of the vehicle within 1 mile per hour on a level road. Here are two examples for comparison, one with speed control and one without. With this system, if the vehicle is descending a gradient, the speed limiter may not be able to control the vehicle's speed. However, on some speed control systems, if an overspeed condition occurs, the retarder is switched into operation to contain the maximum speed. On some speed limiter systems, a control switch is available which enables the driver to select lower maximum speeds if required to meet local speed limits. By pressing the appropriate button, the maximum speed is limited to 33, 43, 53 kilometers per hour. This button at the top reverts the vehicle maximum speed back to the maximum legal limit. The next section of this program will deal with the general fault diagnosis and give guidance as to what action and checks can be made to locate the fault. First, let's look at a condition where the engine will not start. On the assumption that the engine is cranking correctly, a check should first be made on the stop control lever on the fuel injection pump to ensure that it's not stuck in the stop position. If it is correct, you'll be able to push it towards the stop position, and when released, it should spring back. Should the lever fail to move, the problem may be that the stop control solenoid is permanently energized due to an electrical fault, or the controls within the injection pump have seized. If all is in order, your next check is for air in the fuel system. However, before conducting these tests, let's briefly look at the fuel system components and layout. The fuel tank can be fitted in a number of different positions, depending on specification. on the left-hand side, at the rear, or the more standard position here on the right-hand side. From the fuel tank, fuel first passes through a fuel tap and onto a primary filter, which is responsible for collecting large dirt particles and water that may be in the fuel. From the filter, the fuel passes to the lift pump, which is mounted on the fuel injection pump. From here, it passes to two filters on the left-hand side of the engine, which provide final filtration before the fuel is passed to the fuel injection pump and pumped at high pressure into the engine. In order to bleed the fuel system, release this screw on the fuel filter, unscrew the lift pump plunger, and operate the pump. If there is air in the system, continue pumping till it's clear. To complete the exercise, release the bleed screw on the fuel injection pump and again operate the lift pump. Should the engine now start, you should report this condition so that the fuel supply pipes can be checked. If there is a continuous flow of air and fuel from the bleed screws, this indicates that the air is being drawn into the pipework between the lift pump and fuel tank. Alternatively, if there is no fuel present, there may be a blockage in the system or a faulty lift pump. However, as a final check, ensure that the fuel tap is on by the primary filter, and also the fuel tap on the engine if fitted.